Hi guys. All right. Um, I know that we're probably so sick of decimals, but we have just a little bit more work left to do with decimals. And then we will close that chapter. But for right now, we are going to transition. Now that we know how to read and write decimals, we're going to start working on comparing decimals. So just a recap of last week, remember that when we are reading or writing decimals, we're always going to give it the label of the smallest place value or the place value that's furthest to the right. So for example, if I have 3.875, my 5 is in the farthest place value to the right, and it's in the thousandth place. So we know that we're going to be talking about so many thousandths, right? Remember that when we have a mixed number, meaning that we have a number and then a fractional part, we're going to say that we have 3, and then we use and for that decimal, 3 and then I'm going to ignore the rest of it and just look at the 875 as 875 thousandths. And last week, if you still have questions about why we call it 875 thousandths, refer back to our lesson from last week. So we're going to say 875 thousandths. And clearly, this is not how you would write it out in word form, but this is just what I'm using to go ahead and refresh. So we have 3 and 875 1,000ths, right? So this is going to come in handy now that we are working on comparing decimals, because let's say, for example, that I have 3 and 870 thousandths, right? So I still have a number in the thousandths place, so that's why I said 870 thousandths, not 87 hundredths. I'm going to say I have 870 thousandths, and I'm going to compare that to 875 thousandths. So really what you want to think about is what is greater, 870 or 875? The fact that they're thousandths doesn't matter really at this point, right? Because we're comparing 870 of something, in this case it happens to be thousandths, to 875 of something, which also happens to be thousandths in this case. So in this case, we can see that 875 is going to be more than 870. In fact, it's 5 more, right? Because we have, if we were counting, we would say 870, 871, 872, 873, 874, 875. So when we're dealing with decimals, we're really going to be thinking about that place value, how we say the how we would say or write the decimal, and that's going to help us when we are going to compare those decimals to each other. Now, let's go back to my example and just say that instead of it being written as 870,000, let's say it was written as 87 hundredths, right? So now I have 3 and 875 thousandths, and I have 3 and 87 hundredths. So remember, when we're comparing, first of all, we want to go, just like with our whole numbers, if we're comparing, we're going to look at the largest place value first, right? So we have 3 and 3 in the ones place. If I had 3 and 1 in the ones place, we could stop right there and say that 3.875 is going to be more than 1.87 because 3 is more than 1. But we don't. We have same, same. So let's go to the next place value. Same, same. Next place value, same, same. And then we're out of gas and we don't know how to compare these two. So remember that when we are looking at fractions, and again, the relationship between decimals and fractions is really, really close. They're really, really good buds. We want to use common denominators. So just like when you're comparing fractions, if you compare 2/4 and 1/2, You're going, I don't know what that is, teacher Jess, because they do not have a common denominator. Actually, you guys are saying, well, actually, teacher Jess, I do know the answer to that because I've already studied fractions. Yes, you have, and that's why I'm making this connection. So we have 2/4 and 1/2. I can't really compare them right now at this point. You guys are smart, so you're already seeing what they compare as. But I need to first change them to have a common denominator. So remembering that I can change 2 to a 4 by multiplying by 2. What I do to the bottom, I have to do to the top. So then I'm going to get an equivalent fraction. Remember, equivalent fractions are fractions of an equal value, but using different numbers. 1 times 2 is 2. 2 times 2 is 4. Oh, I can easily see that 2/4 and 1/2, or 2/4, is equal to each other, right? So we're going to do the same thing with our decimals. We're going to think I have 87 out of 100, and I have 875 out of 1,000. Now 100 and 1,000 are not the same, so I need to first find a common denominator so that I can compare these two. So just like I did when I was separating out each place value, I know that 100 can be multiplied by 10 to get me 1,000, so I'm going to do that down here. What I do to the bottom, I have to do to the top. So now I come up with a fraction that is over 1,000. 87 times 10, that's like 87 tenths, or 870. Now I can compare them. Oops, that's not right. So now I have 870 thousandths, or 875 thousandths. We're right back to where we started if I had put a 0 in here. And we can say that 875 thousandths is greater. Okay, I realize that was whipping through stuff because that's basically the whole lesson in a nutshell. So if you got that, great. Don't stop. Keep going through the lesson. You're not done yet. You're not off the hook. But great that you got it. Yay, hooray. Okay, so let's go ahead and now go back into your packet to see what the book has to say about things. So we're actually going to be starting on page 172. The problem says, Gary and Melissa compare the distances they bike each morning to get to school. Gary bikes, so I'm going to write G for Gary. He rides his bike 3.275 kilometers. So Gary and Melissa must either be in Europe or Australia, or really pretty much any place except for the US. Or maybe they're in the US and they just like working with the metric system better because frankly the metric system is better. Okay, so Gary rides his bike 3.275 kilometers each day. Melissa, on the other hand, rides her bike 3.24 kilometers every day. So now we're going to be using a couple of different ways to show how we can compare our numbers. So I'm actually going to skip down to the second model-it, which is that we can use a place value chart to compare our two decimals, right? So if I write out my place value chart, I know that I'm going to have a certain number of ones. Then I have my decimal. Then I'm going to have tenths, followed by hundredths, followed by thousands, right? So these are the place values that I have in these numbers. So now I'm going to go ahead and fill in the numbers. So for Gary's time, I'm going to put a 3 in the ones place, a 2 in the tenths place, a 7 in the hundredths place, and a 5 in the thousandths place. For Melissa, I'm going to do the same thing. I'm going to start with my 3 in the ones place. I have 2 in the tenths place, and 4 in the hundredths place, and I don't have anything written in the thousandths place. So remember, just like when we're comparing whole numbers, when we're comparing up into hundreds and thousands and everything, this is what we covered last year in 4th grade when we're comparing numbers that are greater than 100. We're going to always start with the greatest possible place value, or the one furthest to the left, right? Because again, if Melissa only rides her bike 1 and a fraction of a kilometer, and Gary rides his bike 3 and a fraction of a kilometer, we don't really care about the fractions. We just know that Gary rode more than Melissa because he rode 3 and she rode 1. But that's not what the problem says. The problem says that they both rode 3 whole kilometers. Okay, so that's the same. So now we're going to move to the next place value over to compare. Oh, also the same. So they both rode 2/10 of a kilometer as well. So we're going to keep moving. When we get to the hundredths, we see that Gary biked 7 hundredths more of a kilometer, whereas Melissa only biked 4 hundredths. So if we were to write that out, we could think of it as 7 hundredths versus 4 hundredths. So again, remember, whenever we're comparing numbers, it doesn't matter necessarily what we're comparing as long as we have the same thing. We have 7 of something and we have 4 of something. Which is more, 7 or 4? 7. So 7 hundredths is going to be more than 4 hundredths. Therefore, Gary rode his bike farther. Now, I'm going to change the problem again, just like I did before, because I like changing problems to make my point. I'm going to go ahead and change the problem. Oops, actually, I'm going to leave Melissa's as the same, and Gary's is the one that I'm going to alter. So let's say that now Gary rode 0 hundredths. So he rode 3.205 instead of the 3.275 that this story tells us. And Melissa still rode her 3.24 kilometers. Okay, so we're going to go through the same process. 3 and 3, same. So now we're going to move to the next one. 2 and 2, also same. Now for hundredths, we have 0 hundredths and we have 4 hundredths. So let's go ahead and write that out. I have 0 hundredths, or I have 4 hundredths. Which one would be more? Well, let's think of it this way. When we're comparing 0 of something and 4 of something, 4 is going to be more, right? So now we've switched it so that Melissa actually rode farther than Gary, because she has 4 hundredths of a kilometer in there and Gary has 0 hundredths of a kilometer. So it doesn't even matter that he rode an extra 5 thousandths of a kilometer, because the fact is that Melissa had 4 more hundredths of a kilometer than Gary did. He had 0 hundredths. So place value and where the zeros are is really going to be important as we are comparing these decimals. Now, again, I changed that problem to demonstrate my point, but one way you could go ahead and compare decimals is with a place value model. So that was the second model it on page 172. And that's my preferred way to think of it, because I like lining those things up because it makes it really easy for me to think about. But let's go back to the first model. The first model, it says you can express the two distances as mixed numbers with like denominators. So remember that we have to have the same denominators in order to compare fractions. So if I write it as a mixed number, I have 3 and 275 thousandths, right? Because the 5 is in our thousandths place. If I wrote Melissa's number, I would have 3 and 24 hundredths, because the 4 is in the hundredths place. Now, as of right now, I do not have a common denominator. I cannot compare these two because I'm comparing thousandths and hundredths, and those are not the same. So my first step is going to be to figure out what a common denominator would be. So just like we were doing in our last lesson, I'm looking at 100. I know that if I multiply it by 10, I will get to 1,000. What I do to the bottom, I have to do to the top. And so that's going to get me 100 times 10 is going to be 1,000. And 24 times 10 is going to be 240. So now I can compare. I'm going to rewrite my fraction with my new same denominator. Oops, what am I doing? 240 over 1,000, right? And so we're basically thinking of it the same way that we did with the place value model, where basically all I did was add a 0 here, right? Didn't change the value of it, but I did change what it was called. Now instead of 2,400, it's 240,000. So that's why we say the last place value, even if it's 0, we still always call it by the least place value, because 240,000 is different from 2,400 when I'm comparing my two fractions. Okay, so let's change it back. So now I have 275 of something versus 240 of something. We know that 75 is going to be more than 40. Therefore, 275,000 would be more than 240,000. Therefore, 3 and 275,000 is more than 3 and 240,000. Okay, we're working hard for our math today. So we're going to go ahead and skip on over to page 174. And I heard from some of you that pausing the video now does not work. Yet another delightful wrinkle that distance learning has provided for us. So we're going to just go ahead and work through the problems on page 174 together, okay? So if you get stuck, you can just pause the video. If I'm going too fast, just pause the video, look at the problem, and then restart, or not restart it, but play it when you're ready again. But don't try and toggle back and forth with wait. Is it even pausing that doesn't work? I don't know. Maybe don't pause it. Just try and keep up. I don't know. Okay, number 7. Braden and Kayla measured the width of their kitchen tables. Because of course they did. Because they're home with COVID and there's nothing else to do except for measure tables. All right, Braden's table is 1.46 meters. Again, people living maybe in Australia or someplace that values the metric system. Kayla's table is 1.62 meters. We're comparing meters and meters, not meters and kilometers. You don't have a kilometer long table. Whose table is the widest? Okay, so again, if I'm thinking about place value, it does say to show your work, so you could show it as a fractional model. I would again recommend, I really like that place value table to compare fractions. So how you would draw that is you're going to start with a rectangle. And then you're going to see that we have 1, 2, 3 place values in each number. So I'm going to go ahead and make 1, and then I'm going to leave a spot for my decimal point. So then 2 and 3 place values with our decimal in here. And I'm going to divide off this first top just so that I can put labels for where things are. So we have 1s here, we have tenths here, and we have hundredths here. And you can write out the words for each of them, but I find that I run out of space really quickly, and so it's nice to go ahead and just write it down as the place value number. So for ones, in the ones place, for both numbers, I have 1, right? So now I'm going to divide my box in half again because I'm comparing 2 different numbers. So I have 1 for Braden's table and 1 for Kayla's table. All right, now I'm going to go to the next place value over. 4 and 6. Braden has 4 tenths and Kayla has 6 tenths. But I'm going to finish going on, even though I can stop right there to do my comparison, but I'm going to keep writing in my numbers. So now Braden has 6 hundredths and Kayla has 2 hundredths. Okay, so if we were just going to look at this, let's ignore our ones because those are the same. Let's ignore our decimal point. If we were just to look at these numbers as 46 of something versus 62 of something, You guys know that 62 of something is more than 46 of something. So even though our hundreds place would be more on our top number than our bottom number, we don't include that in our calculation of comparisons, right? We want to just look at the greatest place value that makes the difference. And in that case, that number falls in the tenths. So Braden has 4 tenths, Kayla has 6 tenths. Kayla is going to have the longer table. They're really, really close. They're only off by like 2 tenths, not just 2, like 2 tenths, like, well, yeah, like 2 tenths of a meter. So they're really pretty close in width, but Kayla does have the longer table. So, or the wider table, I guess we're measuring width instead of length. So this is one way that you could think about it. I'm also going to show you the fractional model, just in case. So we could think of it as we have a mixed number, right? Because we have 1 and, so 1 and 46 hundredths, right? Because our 6 is in our hundredths place, versus 1 and 62 hundredths, because our 2 is in our hundredths place. And what's nice about this problem is that we already have common denominators. I can go ahead and compare 46 hundredths to 62 hundredths and say with ease that 62 hundredths is more. And so then what I would write in on the solution is that Kayla's table is wider. Okay, so that's coming back to what the question was asking. I'm not just writing in my work. This is how I'm showing my work. But then to actually answer the question says, whose table is the widest? Kayla's table is the widest, or Kayla's table is wider. Okay. All right, number 8. Heather's rabbit has a mass of 2.190 kilograms. Jelani's rabbit has a mass of 2.195 kilograms. Write an inequality statement comparing masses of the rabbits. Inequality statement just means you're using greater than, less than, or equal to symbols for. And whose rabbit has the greater mass? Show your work. So again, you can use a place value model, but we can also just see, right, that here we have 2 and 2, 1, 1 and 1 tenths, 9 and 9 hundredths. But here we have 0 thousandths, and here we have 5 thousandths. So we could just go ahead, and because we're dealing with thousandths and thousandths, we could say that 2 and 195 thousandths is more than 2 and 190 thousandths, right? You could also think of that as 2 and 195 out of 1,000 is still more than 2 and 190 out of 1,000. Okay. Now again, that's not just, so that would be for our inequality statement. You could write either of these for your inequality statement, but then it also says whose rabbit has the greater mass. This was Heather's rabbit, and this was Jelani's rabbit. So Jelani's rabbit weighs more or has a greater mass. Okay. All right. Number 9, we're going to skip because I feel like skipping it. Okay, so pages 175 and 176 are going to be for our practice session on Thursday. So go ahead and skip on over to page 178 now. We're going to look at the problem on page 178. Okay, so Tyson runs in a race. I'm sorry, we're also kind of switching gears here now to rounding decimals. So, but we're going to follow the same exact principles that we do with greater numbers. So remember, if we have, let's see, 276 as our number, and we want to round to the nearest 100, my 2 is in my hundreds place, so I'm going to think 276 is going to fall somewhere between 200, which is the 100 that it's at, and the next 100, which would be 300, right? So now then I need to think about where on that line 276 falls. So I know that right in the middle would be 250, right? So 250 is halfway between 200 and 300. 276 is going to be along this line. So, and I know that 275 would actually be halfway between 250 and 300. So I'm going to put it just a little bit over from halfway. So 276, I'm going to say, is about there. We see that it's closer to 300 than it is to 200. And so 276 would round up to 300, right? Now the rule is, so we could do a number line every time we want to round a number, but the rule is you look to the place value next to where you're going to be rounding to. So if I'm rounding to hundreds, I'm going to look next door. The rule is 5 or more round up, less than 5 round down. So 7 is more than 5, so that means I'm going to round up. And again, if I'm rounding to hundreds, that means that this number is going to go up by 1, and my other numbers are going to all turn into zeros, right? Now let's go ahead. I know that this is review of rounding, but it's worth reviewing. Let's say instead of rounding to the nearest 100, I'm going to round to the nearest 10. So now I'm looking at the tens place. I'm going to look at the number next to it. That number is 6. 6 is 5 or more, so I'm going to round up again. So the nearest 10 I would have between 270, right, would be a 10, or 280. So in this case, if I'm rounding 276 up, my 7 is going to round up, so my 2 stays the same. My 7 rounds up by 1 more number to 8, and all the numbers next to it turn to 0, and that's just the 6 in this case. So 276 would round up to 280. So that's a little bit of review of rounding, which you guys already know because we have already worked with rounding numbers like that. We've worked with rounding even bigger numbers than hundreds. Now we're going to be working with rounding decimals. Same exact principle applies. So my big takeaway with decimals with you guys, my big takeaway from these lessons is that it is really no different from any other place value work that you are doing. So let's go ahead and come back to the problem on page 178. Tyson runs in a race at a track meet. One stopwatch shows his time as 11.25 seconds. Another stopwatch shows his time as 11.245 seconds. Okay, so this is why at professional races they have multiple clocks, because sometimes like if you're just holding a stopwatch and you're like, there's a fraction of a second that goes by between when somebody says go and when you actually start the timer. So they have all of these different times so that they can compare them, and if you didn't get the time exactly right, you can find somebody else who maybe got closer. So for this one, we're going to be rounding it to the directions say to round each time to the nearest tenth of a second, because I would think that we would want to compare the two and see which one maybe was closer to the actual time. But right now we're just going to focus on rounding. So we're going to round each time to the nearest tenth of a second. So that means we're looking at the tenths place, right? Okay, so we have a picture of how you can think about this and a model. And again, this is no different from our place value work with whole numbers, right? With numbers 1 all the way up to 1,000,000 plus whatever. It's no different. So we have two strategies here. We can use a number line and think about where our numbers are going to be starting and stopping. So if we're looking at tenths, I'm going to just ignore what's next to it and say that we're looking at 11.2 on one side, 11 and 2/10. And then on the other side, if that were to round up, right, then the next tenth that we would come to would be 11 and 3/10, or 11.3, right? So on the two ends, we have the nearest tenths. So we have 2/10, the 2/10 that we already have, and we have 3/10, which would be the next tenth that we would come to, counting by tenths. Now we're going to look at these numbers to the right and see if we get closer to 11.2 or 11.3, right? So first of all, let's think about what is the halfway point between both of these two numbers, 11.2 and 11.3. So what would be exactly halfway? Well, again, if we thought of this as like 20 and 30, then we would know that we have halfway in between 20 and 30 would be 25, right? So no difference here, except that we have 11 in front of it and a decimal point. So if we have 11 and 2/10 and 11 and 3/10, we can think of that as 11 and 20 hundredths and 11 and 30 hundredths, which would mean that we'd have 11 and 25 hundredths in between. So now let's go ahead and place our two scores. Well, actually one of them is 11 and 25 hundredths. The next one is going to be thousandths, right? So now we need to think about where that one would be. So here's 11 and 25 hundredths. What would be the next hundredths that I would come to? If I was counting on, I get 11 and 26 hundredths, right? And then 11 and 27 hundredths, 11 and 28 hundredths, 11 and 29 hundredths, and 11 30 hundredths, right? So I have 11 and 26 hundredths would be the next one. So now I have 11 and 245 thousandths. So I have 11 and 25 hundredths, but here it's like I have 24 hundredths. I have 5 thousandths added to that. So that's going to be less, right? Because 4 is less than 5. So 5 is right here. So I'm going to need to go down 1. Make some room. So the next one down then would be the 11 and 24 hundredths. Okay, so now I need to figure out where the 11 and 245 thousandths would fall in between that. So that would be like saying that we're going to take our hundredths and divide it into tenths, right? Because I would have 11 and 24 hundredths, 11 and 24, 244, 11 and 240 thousandths, and 11 and 250 thousandths. So then I would have 11 and 241 thousandths, 11 and 242, 243, 244, 245, 246, 247, 248, 249, finally reaching to 11 and 250 thousandths. So if we were looking at that, we would see that our 245 thousandths would be halfway between 11 and 240 thousandths and 250 thousandths. So it would be right there. So looking on our number line, if we were going to round them, we would say that 11 and 25 hundredths is located in between 11 and 20 thousandths, or hundredths rather, and 11 and 30 hundredths. Our rule is 5 or more rounds up. So our 11 and 250 or 25 hundredths, we would round up to 11 and 30 hundredths if we are rounding to the nearest tenth of a second. On the other hand, our other number, 11 and 245 thousandths, is just below that. And so it's going to round down to the nearest tenth of a second, or 11 and 20 tenths. Okay, that felt really messy to me. That didn't feel clear at all. So what I'm going to do, that is, and that's the thing with having multiple strategies, is some strategies work for you and some strategies don't. Some strategies you may like and some strategies you may not like. Some strategies work well in some situations and not so well in other situations. So even though we're using the number line here, that may not be the best strategy for how you think about this. For me, it's more helpful to think about it either in terms of a place value chart or just by using our rounding rules, right? So if I'm going to ignore my 5 right here for a second, I'm going to think that I have 11 and 25 tenths. So I would have 11, again, if I'm going to write a number line, I would have 11 and 20 tenths on one side and 11 and 30 tenths on the other side. 11 and 25 tenths, or I'm sorry, hundredths. 11 and 20 hundredths, 11 30 hundredths, and 11 and 25 hundredths would be in the middle. So I know that my rule is 5 or more rounds up. So I have 5, I'm going to round it up to the next one, because I'm looking to the next place value next to tenths, right? So tenths is what we're rounding to. Look next door. 5 or more rounds up. So that means this number is going to change to a 3. This number is going to change to a 0. And we get our 11 and 30 hundredths. Now let's use the same principle with our 24 hundredths. I'm still rounding to the nearest tens. I'm going to look next door to the hundredths. Is it 5 or more? Nope. Rule is if it's less than 5, we round down. So that means that this number is going to stay the same when we round down. And this number is going to change to 0. Okay? So that's the basic principle that we're working with when we're rounding. That's going to be like the short and sweet, simple addition, right? I totally took out the thousandths because the thousandths are, we're talking about tenths here. And what's going to determine whether we round up or down with tenths is the hundredths place. So I don't even need to think about the thousandths place unless I'm working with that super complicated number line that I showed you before, which maybe made sense. That's great. If it didn't, if you're like, ah! Remember the rounding rule. Keep it simple, okay? I want to still go over the model it where it says using a place value chart, okay? So I'm going to make my place value chart again. And I'm going to have, now in this instance, I have 10s, and then I have 1s, and then I have my decimal, and then I have tenths, hundredths, and I did even have thousands in here, right? So I'm going to go ahead and change these back to reflect what the problem originally has. We have 11 and 25 hundredths and 11 and 245 thousandths. Okay. So if I were to fill in my place value chart, I would have 1 decimal point, 2, 5. And then I'm also going to have my 1 decimal point, 2, 4, 5. So now I'm going to actually end up expanding my place value chart because now I'm going to add in what would be the next place value in the tens place above and what would be the next place value in the tens place below, right? So below would just mean that it would stay the same. Okay. So these are the two numbers that I have. If I kept all of my place value numbers the same, There we go. And I round up my tens place. So here we have one decimal point is going to be the same, right? So I'm just focusing on my tenths place. I have 2 tenths in both of them. So tenths could either stay the same as 2 tenths and no other place values, or it could go up to the next tenth, which would be 3 and no other place values, right? So then I would need to think about which one it would be closer to. 11 and again, I'm going to use my rounding rule. I have 2 in the tenths place. I'm going to look to the next place value over. Rule is 5 or more rounds up. So I'm going to round it up to 11 and 3/10, or 11 and 245 thousandths. I'm just going to look at my tenths again is where I'm rounding to. So I'm just going to look next door. 4, my rule is 5 or more round up. If it's less than 5, round down. So 245 thousandths is similar to saying I have 200. I could round it to 24 hundredths. So it's going to be closer to 2 tenths than to 3 tenths. Okay. Let's go ahead. We're going to skip on over to, and I know that that may be confusing with the rounding, with showing it, but I think you guys will get the principle because, again, it is the same exact procedure as rounding with whole numbers, okay? If I were to erase this column, it would be like we were comparing 11,250 to 11,245. 11,250 is right in the middle, right, of 11,200 and 11,300. If I look at my hundredths place, let's say that that's the place value I'm going to round to. I look to the number next to it, 5 or more rounds up, so we would round up to 11,300. Here, I'm looking at my hundredths place again. I look to the number next to it. It's 4. That's less than 5, so I'm going to round down to 11,200. Now, I think the stickiest thing, the stickiest, trickiest part of rounding is that when we say round down, it really means we're not changing the number, right? So when we round up, so here, using our example of 11,245, if I were to round up, then I change my hundredths place to the next number up, which is a 3, and all the other numbers change to zeros. But if I round down, my hundredths place is going to stay the same. So rounding down means you're staying in that same place value. Doesn't mean that you go down to the next one. I'm not going to round down to 100. Because if I were counting by hundreds, I would count like this, right? 11,100, 11,200, 11,300. So 11,245 would be somewhere between these two hundreds. And so by rounding down, I would round down to the 200. So that's the trickiest part, I think, about rounding, is making sure that when you round down, you don't round down too far. But with decimals, it's going to be the same exact procedure as rounding with whole numbers, okay? So we're going to go ahead and take a look at the problems on 180. And I know that you guys can't pause your video, so we'll just go ahead and, again, work through these together. So Belinda paid $108.34 for groceries. Pause. Money. Money can sometimes be the best way to think about decimals because we're thinking of a certain number of dollars, right? And our fractional piece is a certain number of cents. We have tenths of a dollar and hundredths of a dollar, right? Because 100 pennies would make up $1. So if I have 2/10 of a penny, that's like, or I'm sorry, if I have 2/10 of a dollar, that would be like saying we don't have that, but I would have 20 cents, right? If I have 5/100, I have 25/100 of a dollar, or I have 1/4 of a dollar, right? So money can be a really powerful way in helping to understand decimals. So if you find that you are struggling with any of the concepts of decimals that we have been going over, ask your mom to give you a higher allowance so that you can start working with decimals. Okay, so Belinda paid $108.34 for groceries. Rounded to the nearest dollar, how much did Belinda pay for groceries? Show your work. Okay, so a way to show your work, you could use a number line model. You could also use a place value chart. Again, number lines have their time and place. We can use that one. Yeah, we might as well show it. Okay, so remember, we're rounding to the nearest dollar, which means if we're looking at our decimal from a dollar perspective, we have $100, $10, and single dollars, $1, right? So if we're looking to round to the nearest dollar, we're going to be looking at this place value right here. Okay, so that's going to be our target. So thinking about the closest dollars, we would have $108 on one side, right, and no cents. And then the next dollar that we would come to would be $109 and no cents, right? Now halfway in between, what is half of a dollar? 50 cents. So halfway between would be $108 and 50 cents. So now we need to think, is 34 more than or less than 50 cents? It's less than, right? It would fall right about here, $108.34. So that shows that we're closer. If it were here or anywhere through here, we would round up to $109. But since it falls on this side of our number line, it's going to round down to $108. So Belinda's groceries rounded to the nearest dollar. She paid $108. Okay? Don't forget the dollar sign since we're talking about dollars on your solution. Okay, let's look at number 9. See? Decimals. Easy peasy. Let's look at number 9, and this time we're going to use a place value chart. So a dropper holds 0.817 milliliters of fluid. What is the amount rounded to the nearest hundredth? So I'm going to draw my little box around my hundredth place, and that's what we're going to focus on. So I'm going to draw my place value chart. I'm going to think of the number above and the number below. Our number is 0.817. So I have, if I'm going to read my decimal, I have 817 thousandths of a milliliter, right? Because our 7 is in our thousandths place. So now I'm looking at the tenths place, I'm sorry, the hundredths place. So now I want to look at, so the next tenth that I would come to would be 2. So that would look like 820 thousandths. The one below it would be 810 thousandths, right? And that makes sense because if we're counting by tens, it would say 10, 20, 30, 40, 50, so on. So we're looking at 817 thousandths, if it would round up to 820 thousandths or 810 thousandths, or round down rather to 810 thousandths. So if I'm looking to round my tens place, then remember I'm going to actually look at the number next to it to see if it's 5 or more and if I would round up or down. So 7 is more than 5. So we're going to round up, which means that we're going to round to 820 thousandths of a milliliter. Okay? So this is what you're going to write on the solution line for number 9. We are also going to skip number 10 just because I don't want to go into the multiple choice ones with this. I feel like you guys have enough information based on the couple of examples that we've done. Pages 181 and 182 we'll also cover in our practice session, and then 183 through 186 are there for extra practice if you would like, but again, that is, as always, optional. All right, friends, I will see you next time. That's it for this lesson. Hopefully I didn't confuse you too much, and don't forget to ask for that increase in your allowance so you can practice decimals. All right, bye, friends.